Hey guys, it's me again. So in this video, we'll be focusing more on the idea of correlation. To take a quick recap on what the term correlation means. So we're trying to study the association between two quantitative variables. So basically what I mean is that we're trying to learn if there is some relationship between two variables that we're working with. I'm just going to try and share my slide so that we can. Hey guys, it's me again. So in this video, we'll be focusing more on the idea of correlation. To take a quick recap of what the term correlation means, we trying to learn if there is association between two quantitative variables. Basically, what I mean is that we are trying to learn if there is a relationship or a statistical relationship between two variables. So I'm just going to quickly share my slide so that we can see what I mean. As we already know that correlation is divided into two parts. We can either have positive correlation or negative correlation. I think these two terms are self-explanatory because we know that if the R value is positive, then we have a positive correlation. Same applies to negative correlation. If the R value, which is the correlation, if it's negative, then it means we have the negative correlation. But remember that we can either have a strong or a weak correlation. What do I mean by that? Both on positive and negative, we can either have strong or negative or weak correlation. So let's start with the positive correlation. If the R value is a positive value close to 1, then we say that is a strong positive correlation. And if the R value is positive value but close to 0, then we say that is a weak positive correlation. Same applies to the negative correlation. If R is a negative value close to -1, we say that there is a negative or there is a strong negative correlation. And if R value is negative but close to 0, we say that there is a weak negative correlation. We can also see that it's being illustrated by graphs. If there is a strong positive correlation, we can see that the graph is an increasing graph and it's positively sloped. But if it's a weak positive correlation, we can see that it's almost more like a horizontal line, but it's a horizontal line that's increasing a bit. So same applies to the negative correlation. If we have a strong negative correlation, we can see that is a decreasing graph, meaning it's negatively sloped. So if it's a weak negative correlation, we can see that it's almost a horizontal line, but it's a decreasing look-alike horizontal line. So basically, this is what we will be doing, or this is what you will come across most of the times during exams or tests. So I'm just going to quickly move on the next slide so that I can just demonstrate this using the example. On the previous slide, we have learned that if we have two correlation, the correlation can either be positive or negative, and given that we can have a strong or a weak correlation. So let's go back to our example. So moving on, we can see that here we are actually given the results of mathematics and English, and we have 3 students, namely John and Peter and Reg, and we are also given their results per subject. We can see that John has obtained 8% in mathematics but 25% in English. Peter has obtained 55% in math and 50% in English. Lastly, Reg has obtained 19% in mathematics but 75% in English. And you can also see that I've already managed to draw the line of best fit, or instead regression line. So when calculating the correlation value, you are also, or you are still going to follow those steps that I've shown you on the previous video. So you are still going to have that step whereby you enter the data that you will be given. So I'm just going to demonstrate that again, but I'm just going to make it more quicker than on the last video. So remember that you start by pressing shift, then followed by mode. No, it's mode, then you select option number 2, and then after that you also select option number 2 that's written a plus bx, and then something that's going to show afterwards is a table of x and y. Then from there you are going to enter those values that are given here. For instance, here we have 80, 55 and 19. So you are going to enter those mathematics value on a same column. So you can decide if you want to enter them either on the x column or on the y column. It's not going to make any difference on your r value. So after you have entered those values, remember we don't work with that button at the top right. We only work with AC. So after you have entered or plugged in those values in those tables, you are going to press AC, and then after AC you are going to press shift 1, and then after pressing shift 1 you are going to select that option. It's option number 5 named reg. I think it's reg for regression. And then after pressing that option 5, something that's going to display is A, B, R, and what. So here we are at that point where we will select option A or B by the time we will be we were calculating the line of best fit. But since now we are no longer calculating the line of best fit, we are now on the correlation. So here you are going to select option number 3 that's named R. And then after selecting option number 3, you're going to select the equal sign, and the value that's going to display is the one that we have here. It's negative 0.999462. This value is the correlation value, but let us interpret what this value means. So let's move back to the previous slide. So here on our answer, we can see that the answer is negative to start with. It's negative. So by that only, we can know that, or we can deduce that this is a negative correlation. But at this point, we don't know if it's weak or strong. So let's look the entire value. This entire value is negative 0.9962. We can see that this value is close to -1. It's close to -1. So this, to interpret this, or in interpretation to this value, we can deduce that, or we can conclude that there is a strong negative correlation between these two variables. And I've already mentioned on the previous video that in mathematics you must be able to know what the values that you calculate actually mean. So let us interpret this. I've already mentioned that when talking about negative correlation, it means that two things go in opposite direction. What do I mean by that? Basically what I mean is that if the other one increases, then the other one will decrease. And we can see that happening here in this example, that John has scored 80% in mathematics. Then his English result were what? 25%. So we can see that his math results are high, and then his English results are high or low instead. So with Peter, they are both at the middle. And then moving forward to Reg, we can see that his mathematics results are at 19%, and then his English results is 75. So we can see that if the other one decreases, then the other one will automatically do what? Increase. So we can see that there is a negative relationship between these two variables. If the other one increases, then the other one will definitely decrease. So I hope this video makes sense, and I hope you all understand the idea behind the correlation and what do we actually try to mean. And I hope that if you come across this kind of question during exam, you can be able to enter your data correctly or proper, because remember, during exam you're going to have a limited time, so you're not going to have enough time to be making so many mistakes and canceling, going back. And also remember that when calculating the line of best fit or regression, we don't work with that button on at the top, right? We only work with AC and then follow all other steps. And I wish you all the best in your upcoming exam. Can you please just comment on the comment section below, or which topics do you want us to tackle in the next video? Cool.